All right, so this is solving trigonometric equations. And these equations are going to look just like the linear and quadratic that we dealt with before. We're just going to have to do a little modifying to get there. You know, remember that on this page, the beginning, we just want our answers for x to be between 0 and 2 pi. So it will be just on the unit circle itself. So if we get any of these exact answers, then we will give the exact answer. So any of these angles will be given if this is what our function equals. If it's not, then we use our calculator. All right, and you also need to remember that our sine and cosine have to be between -1 and 1. These are the things that we want to look for. So remember, if the ratio is on the unit circle, give the exact answer. If it's not, then you use a calculator with the inverse to find it. So let's try one. So what I like to do is if you see cosine of x and you know how to solve it, we need to make sure we just subtract 1. We get cosine of x equals -1. Now, on some of these, they will seem difficult. So the default is to just say that our a here equals cosine of x, and then you can do a little substitution. And we get a plus 1. Now, this is a nice, easy linear equation. I guarantee you could see that you just subtract 1, and you get a equals -1. And then now you can plug that cosine back in. So now we have cosine of x is equal to -1. So you pull out your unit circle. Cosine of x is the x coordinate, so it equals -1 when we have pi or 180. So you just need to read what it says. If it's asking for the answer in degrees, you write 180 degrees. If it's asking for radians, you write pi. Mine is asking for radians. That's how we started it, 0 to pi. So you say x equals pi. You're done, and you move on to the next one. So now I'm going to be using the a substitution here on every single problem. If you don't need it, you don't have to, but I'm going to be using it on all of them. So here we're going to say a equals sine x. This is our a right here. So now I can take it and replace it with a minus 1, and that gives me my equation. This is just being multiplied. So we do our normal dividing, so we isolate or separate. And then we divide. Now, anytime you're dividing by 2, you want to make sure you rationalize so that it will match what we have. So this is square root of 2 over 2. And then now we do our substitution. So our a here is sine x. So sine x equals square root of 2 over 2. We write x equals, and then we go to our unit circle and we give every single answer that is square root of 2 over 2. So this was sine. Sine is the y coordinate. So square root of 2 over 2, pi over 4. And remember, sine is also positive over here in quadrant 2. So 3 pi over 4. So it's pi over 4 and 3 pi over 4. And that's it. So all you're doing is solving these as if they are linear equations or quadratic, and then writing the answer. So here are some more problems for you to try. So I want you to hit pause and give them a shot. Now, I only need you to try 1 or 2 of them. That's it, not all of them. So I'm going to write the answer for all of them. You decide what you want. Do you want something more difficult, or do you want something easy to give as your intro? So hit pause now and try them, and I will write the answer for all of them when you unpause it. So hit pause now. Okay, so here are the answers. And if you look at a very important one here, we have cosine. Cosine of x is equal to 5. If you remember, our cosine and sine need to be between -1 and 1. So when you get this, this is where you have your no solution. It is not possible to have any angle that will give you a cosine above 5. If you remember, our cosine graph goes between -1 and 1. +1. And then down to -1. It will never come up here to 5. It's not possible. So there is a way to check each of these, which I haven't shown you. So all you have to do is plug this in your calculator. So if you bring up your calculator, again, make sure your mode is in radians, not degrees, because that's what we're plugging in. And you can just enter it in. So one of our answers was pi over 3. So we go 2 cosine of pi over 3, and it should give us 1. So 2 cosine second pi divided by 3. Hit enter. And so there we go. 2 cosine pi over 3 is 1. And that's what we're looking at that. So 2 cosine pi over 3 over 1, it checks. And you can check again with 5 pi over 3 and all the rest. All right. So here's a trick one that they're going to run into. You look and you see sine and cosine, and well, what are you going to do with sine and cosine? Nothing. So a trick you can do is if you divide both sides by cosine of x, you get sine x over cosine of x is equal to 1. Now we can change our sine and cosine into tangent. So anytime you see sine and cosine like this and you can divide, you now have tangent x. So we pull up our unit circle. Sine, tangent is equal to 1 right here at pi over 4 and 5 pi over 4. So we would say x equals pi over 4 and 5 pi over 4. And we can check that again with the calculator. So sine, which we already know is true, come on, sine pi over 4 is the square root of 2 over 2. And we know that cosine of pi over 4 is the square root of 2 over 2. So that's the other way, is you can just use a little bit of logic. When is sine and cosine the same? Right there and there. And then you just say pi over 4 and 5 pi over 4. These are equations, so you got to remember that we are just looking for when they are equal. All right, thank you.